So that's essentially what we'll talk about, at least initially. But that's how you preface it. You put the first thing in, then you put its conjugate in by itself. What does that conjugate mean? That's how you do it. Okay, let's get started. So we'll talk a little bit at the end of class about where we're at, and most likely the test will be when we come back. So let me make sure everybody knows Thursday's the day off, right? It's not some kind of a holiday. I think Friday's the actual holiday, but we're taking Thursday off. We call it instructional day or something. And so when we come back from break, we'll go Tuesday, we'll finish up this chapter, whatever we don't finish today, which is likely just going to be a whole bunch of questions and how to solve them based on what we learned today. So it would be a nice review to the end part of this chapter on Tuesday. We'll pick up whatever time we have left, we'll start a new chapter, and then we'll take the exam on Thursday when we come back, okay? So that gives you some buffer time and some other things you could ask questions before we start the new chapter. The new chapter we start will not be on that Thursday exam. Let me make that clear too. That will be on the future exam. But we just don't want to wait. Yeah, it will be just chapter 16 for the exam. Okay? Okay, let's get started. So we've talked a lot about strong and weak acids and bases and using ice charts to determine the strength of weak acids and things of that nature. We've talked about logarithmic entities such as POH, pH, pKa's, and how they factor in relative to what their original thing is. We're going to now look at, let me see, this is interesting. We're going to look at things like, when I say a strong acid, I say HCl. Okay? If I say a weak acid, I could say something like HF. And all we've looked at is that on its own. Okay? Now we're going to look at what happens if I just have H and I mix it with water, or I just have the fluorine and mix it with water, or something of that nature. So initially we'll look at this and we'll say, what does this do in water, right? Remember, all these things are related to water. If we took it outside of something and put it in something else, this all changes. This is only in the context of H2O. So I want to start looking at, what if I just put that ion into water, or that ion into water, or that ion into water? How does that then change the complexity of whether or not I have an acidic, basic, or neutral solution? Okay? Which is kind of an interesting concept, right? Because this is pretty clearly an acid, this is pretty clearly an acid, and then we distinguish whether they are strong or weak. Now I'm going to say, well, let's break these up, and bases, and ions, and anything else, and if I just put one into water, does that change the acidity, basicity, or does it keep it neutral? And that's the focus. So you're generally going to start with something like this,